quiz as fast as I conceivably can. Let's see here. So number one was to find the basis for the kernel in the range of t, where t was given to be a linear transformation. Right? So, first of all, what are you looking for? Basis, right? Those are sets of vectors. So I'm looking for sets of vectors. Now, how do you actually find those? For this problem, it's, you can look at the standard matrix of T and basically just look for a basis for the column space and a basis for the null space, because those are equal to the kernel and the range, respectively. And so I do that. Now, you guys got lucky, some of you, because it just so happens that the function's surjective, right? So if you choose any three linearly independent vectors in R3, I can't count you wrong, right? But it's an accident that you were able to use these vectors as the basis. If I had created the problem more wisely, I would have chosen a not surjective function such that you would have been wrong if you used these, whereas you would have been right if you used those. Because the column correspondence property tells us that the pivot columns of the original matrix form a basis for the column space. A couple of you used the reduced row echelon form, which wasn't wrong here because it's R3, and any set of three linearly independent vectors will give the same set. So I could take up points, but I know you got lucky. So, but most of you didn't, so it was good. The kernel is just a set of the zero solution, right? So in this case, it works out to 0, 0, 1, minus 1. Any questions about this? I'm going to go on. There are, of course, other choices for the basis, but the basis should be given in terms of a specific vector. A few of you guys had like z minus z here. That's not going to work. I need you to pick a value for c for the basis. The basis is not a set of infinitely many vectors. It is a single vector in this case. You must choose. You can choose z equals to 1, you can choose z equals to 2, whatever. Definitely you can't have a z and a w here. That's not done. Yep.
So you could choose, based on the reduced row echelon form, you could have chosen either 001 or 001, like the third or fourth one.
For what are we talking about?
For the range.
For the range? Oh, yeah, that is true. I could have used column 1, column 2, and column 4. I mean, it wouldn't make a difference, right? Yeah. Like the contrast of white on white there. I don't know. So here, let's move on. Of course, you can see the rank nullity theorem at play. I didn't ask about that, but it's nice to notice that the number of columns is 4, which is equal to the rank plus the nullity, which is the dimension of the column space plus the dimension of the null space, or conversely, the dimension of the range plus the dimension of the kernel. If I had asked about an abstract linear transformation, you cannot do what I just did in this problem. More on that later. Problem 2. Why can't you do it? Because you can't write an abstract linear transformation directly as a matrix multiplication. It has to filter through coordinate maps, you know? Problem 2, you were supposed to find the matrix of T with respect to the beta basis here. And what I have written here is wrong, okay? The last row is incorrect because I made a mistake. I think it was here, no, maybe here. In here somewhere, there's a mistake. So the last row is actually supposed to be, I believe, minus a half, 3 halves.
Yeah.
So there's a mistake on my solution there, which came from multiplying this matrix right here is wrong, and that made this wrong. So that one error I made in the one above made 2 or 3 errors in the row below. That's just how it is. Now this is the fastest way I know to calculate this problem. So for a linear transformation from R3 to R3, the change in basis formula is just a similarity transformation. Of course, as we have discussed, for more general problems of change of basis, you have to go through the coordinate maps, right? But this is like, a special case, nice formula. Also, This is how to find the coordinate map on R3. You take the inverse matrix, right, of the vectors, and times the thing that gives you the coordinate map. That's the fastest way to find the coordinate map in Rn. Again, if this was an abstract vector space, I can't just stick the vectors in a matrix and invert them. It doesn't make sense. I have to do the other kind of arguments we did in class, all right? What I'm trying to tell you is, be careful. What I'm telling you is a context. The context is R3 or Rn more generally, these formulas in this problem. All right, and the arguments of the previous problem are about column vectors.
Wait, what were you doing with the beta matrix there, where you were inverting the diagonal? Like, is that a theorem?
Oh yeah, I mean, so for inverse matrix, if I have block diagonals,
Okay.
a nice trick to know. Oh well. Yeah.
Where?
Right here. Well, this is a block diagonal. It's the one with this block. So the inverse of a block diagonal matrix is the block diagonal matrix of the inverses. Can you stand over here? So for example, if I had A, B, inverse, it turns out, I mean, it's not hard to prove that this is the formula for the inverse. So that's a nice thing to make problems that don't require a stupid amount of calculation. And you can actually calculate the inverse of a 4x4 matrix without doing row reduction if it has this kind of structure, right? And you can see that this works, right? How would you check? A, B, A inverse. How do we do block multiplication? Multiply blocks, right? So this is A inverse plus 0. A times 0 plus 0 times B inverse, and 0 times A inverse plus B times 0, and then finally 0 times 0 plus B times B inverse. Of course, this stuff goes to 0, that stuff goes to 0, and you're just left with the identity. Zeros and the identity again, which of course you might recognize as the identity. So this is just a nice, and I either have a homework problem or I talked about this and there's an example in the notes. I mean, it's come up somewhere, yeah.
And like what you did in the problem there is you just pick the block, like even though it's not a 4x4, like a 3x3, you just pick the block. And
Yeah.
converted that the 2x2 block.
I mean, I said that it was 4x4, but honestly the calculation I just did works just as well if A is 20 by 20 and B is 6 by 6. I mean, but then of course calculating A inverse and B inverse would kind of be a drag. But yeah, here, 1 by 1 block is 2 by 2 block.
Okay. All right. So you can have different sizes.
Yeah. Of course, this was a take-home quiz. You could have used the other method. Right, I just made it so I could be lazy. All right. Some people got this. It was good. The general solution, I did not grade this, number 3, because it hurts me to look at this problem. I just know what I'm going to see when I grade it. And so please look at the answer I have written and contrast it to what you wrote. I'm just speculating. But the general solution should be something like, -1, comma 4 minus z, comma z. Or you could say x equals -1, y equals 4 minus z, and z equals z. Or you could use like a parameter. You could say x equals -1, y is equal to 4 minus t. Z is equal to t. That would be fine. Now, if I ask for the solution set, this isn't the right answer, right? I didn't say for the solution set, though. I asked for the general solution, right? Which is actual vectors, an arbitrary vector solution, yeah.
When you write the particular solution, could you also write in -1, 0, 4?
The particular solution is by no means unique.
Okay.
I don't think I could have written -1, 0, 4, no.
But if
Oh, we
you
meant 0,
said-
yes, I could. Because if I subtract, if I add a to these guys,
Mhm.
eight copies of this to that, that gets me to -104. So if you just take a given particular solution and you add any multiple of homogeneous solution to it, it's still a particular solution. The particular solution is not unique. It always suffers this ambiguity by addition of a null space element. Now, of course, this problem you could have done before we even finished. I mean, this could have been on the last test, right? The reason it's here is because I wanted to draw your attention to the role that the null space plays in the general solution. That's the entire reason that this is here. Okay, so I wanted you to think about that. And if you didn't, you might have still gotten full credit. I mean, everyone got full credit for this one. Yes?
And the null space's effect on it is basically the number of elements in the null space is the number of like free variables or linearly dependent columns.
Right. It's the number of columns minus the number of pivot columns. That's also what I would say. Hey, problem 4, you guys all got right. Almost without exception.
Wait, you did?
Yeah, almost everybody.
I think I finished in 30 seconds.
Oh, yes. Wait a minute. Oh, yes, you put it in this. So what Sharon has done was just, and I'm sorry to tell you on this. Sharon has put a set here. And so like a really quick way to lose most of your points on a problem is write a set where a vector should be, or vice versa.
Right.
Like confuse vectors and sets for me. It makes my grading very easy. I will not tolerate this. You must be clear in your speaking. A set is a set. A point is a point. You cannot fuzzily go between the two unless you're being like systematic about it. There is a way you can replace arguments with points with arguments with sets, but you can't just go back and forth between the two fuzzily, as some of you are at the moment. I'm just saying a very boring thing. I'm saying give me arguments like I've shown you, not ones that are like kind of sort of like I showed you. Like there's a lot of like argument by analogy perhaps, but I want argument by definition and precision. This is what I'm looking for. You should be using definitions and you should be precise. Almost always pronouns are an enemy. You find yourself saying it or this or stuff like that without, I mean, you guys are doing that too much. I don't have anybody in here who's a poet. It's good. Sometimes I've had poets in the past. They're harder to prove that they're wrong, but they're just not clear. Anyway, yeah.
So like the bases are sets, and then
Right. So a basis is a finite set of vectors, which is linearly independent, and it has to span the whole space,
so
or
then-
subspace if we're looking at subspace.
So then when you find V with respect to the bases, that's a set then.
No, I mean, V is a vector, so V it turns out is x squared plus 2e to the x plus 4 cosine x plus 8 sine x. The coordinate vector of V, up here, V sub beta, is 1, 2, 4, 8, because those are the coefficients which appear in the expansion. 1, 2, 4, and 8. And those are unique because of the linear independence that is there for the basis.
It looked like, I couldn't see it very well.
Oh no, that's not curly, these are,
It's,
yeah, that's actually a column vector in my silly notation. All right, problem 5. I'm not going to dilute it and tell you what I wrote on your paper is not shouting. It is shouting. I am shouting at you. Change your ways. You know, shave your head, tear your clothes, ashes, whatever it takes, I don't know. But what you've done is wrong. I mean, it's very wrong. Almost I can say this without exception. There's maybe 4 or 3 of you in here who this does not apply to. When we make arguments in a vector space, we cannot just take the vectors and just make them column vectors. Or pick specific examples of column vectors. Or trade the thing you're given for an equation without an explanation of where the equation came from. These are all forbidden. You must explain where equations come from, especially in proof problems. So, like, I mean, and then there's some other of you who have the right ingredients, but they're just kind of like But there's no like logical connectives, you know? You're telling a story. Yes, I know the proof, but the point is, I shouldn't have to know the proof to read your solution. I should be able to read your solution and go, oh, this is so boring, I've read this. All the other students wrote this too. Like, this is like the solution. I mean, this is not a problem for creativity, okay? This is like, well, I mean, there's some here's where the creativity comes. So, you're trying to show that W plus, oh, I'm sorry, I'm below where the thing looks. So you're trying to show that T is a linearly independent set, right? So what's your first move? Suppose S is a linearly independent set. That is the start of the proof, okay? And then you let T be what it is, okay? If you didn't say that, I wouldn't be too disgruntled because I said it in the problem statement. Okay, I can let that slide if you didn't say let T be that. That's not the end of the world. Not a big deal. I wouldn't have complained about that. But your next move, almost without exception, in these kinds of problems, should be to consider a linear combination of things in T to be 0, right? You don't say a linear combination of things in S is 0. That's true, and that does imply that the coefficients are 0, and you could say note this for later or something, but you certainly don't just say a linear combination of things of S is equal to 0 and then write other equations without words like that. I don't know what that means. To me, that means you don't understand what you're doing quite, or you're still kind of figuring it out. In other words, I will not take your ideas and move them around and logically reorder them until they're right. They have to be written in logical order. It's a proof. So, sorry. I am only trying to help you. Do not mistake my... I'm trying to help. I'm not trying to be mean. Yes?
So whenever we see the word prove, you want a formal proof.
I want correct and complete arguments for every problem. There's no distinction between proof and problems. Everything's a proof. This idea that proofs are different than other things, it's not really a right idea. In math, there are only complete arguments and wrong arguments. That's not quite true. I mean, it depends on your audience. Okay, now you got me. Whatever. Well, I mean, your goal in writing a solution to a test is to show me that you understand the material. Do not let me misunderstand what you're doing as being anything but that. That's your singular goal in taking a test in any class, is to convince the professor that you know what you're doing, right? So think about how can you do that, you know? Like, so when there's an ambiguity in the problem, and as there is sometimes, you should ask, right? Modulo the particular idiosyncrasies using I said. Okay, so like I said, set a linear combination equal to 0, right? What's my goal? My goal is to show that C1, C2, and C3 is 0. I don't even say that at this point though, because I don't want to give you the chance to misinterpret my argument to be circular. So I hold that as an internal thought. I don't write it on the paper, because I don't want to make my reader think I'm giving them a circular argument. Or if I do write C1, C2, and C3 is 0, I say my goal is to show that I haven't done it yet. Let us proceed, or something like that. Something that makes it clear. I'm not assuming it before it's shown. Okay, and then, so then what I do is just algebra, right? I rewrite it as a sum of something with V, something with W, something with X. Yeah.
Wouldn't it be C1 plus C2 minus C3X?
Oh, what have I done? Yes, C1.
Wait.
Well, with V, I only got the V to one spot, so I got C1V. W's, I've got a W with a C1, I've got a W with a C2, and I've got a W with a C3, so C1 plus C2 plus C3. I stand by mine.
No, X is X.
Dx.
And it should be plus C2.
Wait, what?
X is in each variable.
X is in all three, not in just the two.
Oh, yeah, that's true. Oh, man. Well, anyway, okay, so you found the error of my proof. Yay. So, that's good. Yeah, and it's, you know, that's sometimes mentioned. Let's see here. So C1 plus C2 plus, oh, minus C3. So yeah, there's a plus C2 off versus. Oh, man.
Doesn't really change it.
Well, it kind of
Without-
makes the rest
Actually,
a little
it
lower.
does.
My righteous derision has been deluded. Anyway, but at least I made it.
The C2 plus 3 goes 0.
So yes, that would change this equation to C2, which would make the algebra a little bit more of a pain. But the point is, you write down that system of equations, and then you solve it. All right? I don't care how you solve it. You can solve it by adding equations, you can solve it by row reduction, whatever, right? But certainly, you cannot just jump all of this stuff and just jump to the system of equations that comes from C1, C2, and C3. That is very bad form, and it will get you almost no points. You must include these thoughts. These thoughts are not optional thoughts. They must be there. Of course, the corrected version, sorry. But anyway, then you show C1, C2, and C3 are 0, and then you get T is linearly independent, right? So, one of you tried to show that any linear dependence in T would force a linear dependence in S. And you looked at like different possibilities, and you chased down different possibilities, but like, don't do that. That is not the way to argue, because how do you account for all possible linear dependences? You know, there's so many. I don't think that, you covered them all. But anyway, yeah.
Is that derived from the theorem or proposition that, like, basically equating coefficients, or if it's equal to 0, setting each coefficient equal to 0?
Right. In fact, like I said back at the start of all this, sometimes I will really think of that as the definition of linear independence, that the only trivial linear combination is the trivial combination. Pragmatically, that's what works out to be easiest for proofs, right? So, there are easier versions of this question that I sometimes ask on tests, and I hope that you guys can answer them more like I'm showing you here as opposed to what I saw.
We'll get it on the file.
Yeah.
Could you have, if you said, suppose like, if you proposed a basis for T, like, could you have like specifically, if you like clearly said let something be a basis for T and then put it into and defines like a basis matrix, you can't do that?
T is a finite set of vectors. What do you mean a basis matrix for T?
Like, well, if T's a set, there's gotta be some like basis that generates the vectors in the set, right?
T is a finite set.
Yeah,
So you can't generate more, right?
but there has to be a basis for it, right?
No, T is not a subspace. T is a finite set of vectors. It's not a vector space. It doesn't make sense to ask what's its basis. I could look at the span of T or something and then ask the question, what's a basis? But then I think I'm just going to end up being like begging the question. No, I think you got to do what I did there. That's all I know. I did not grade problem 6. Well, no, I graded problem 6. I did grade problem 6. I think it was. Yeah, I did, didn't I? But hey, a lot of you got this right. I think maybe like 50% of the class got this right, which was good, right? And like kind of surprising to me, because in my opinion, this problem is like way more difficult than the one we were just talking about. Like there's a lot more going on here, But anyway, any questions about this one? I can talk about it. Yeah.
I was just wondering if, just saying, that was the next one I had a question. No, wait, no, it is this one.
Okay.
Could you have asked, you asked for T of B beta gamma, with
Uh-huh.
beta gamma. Could you have asked for T of B gamma beta?
No, because
that messes
gamma.
up, like,
No, because gamma is it's a four-dimensional thing. It's for linear polynomials with complex coefficients, whereas beta is a basis for the quadratic polynomials with complex coefficients. What I could have done is I could have asked for T beta beta, and I could have just thought of I could have changed the range to be P2. It would just put a bunch of zeros.
Could you ask for T of gamma gamma?
No, not without.
But-
I suppose I could, but that would really be changing the problem more.
Okay.
Yeah. I mean, there are other ways to modify the problem. So T gamma gamma would require significant modification of what T means. I could do T beta beta by just kind of extending the range and just leaving the new stuff. I mean, a first order polynomial is automatically a second order polynomial, right? But the formula is given for a quadratic, so like, what would I mean if I replace the quadratic with a linear? Like, assume the quadratic piece is 0, I don't know. I guess you can do that.
What do you mean by a first order polynomial is automatically a second order polynomial? Just putting like,
Oh, because we talk about polynomials in the degenerate sense, right? So
okay,
ax plus b is automatically a subset of like the
of like
cx squared plus
AX.
c1x squared plus c2, c2x plus c3. So, in other words, fourth order polynomials are automatically inside the fifth order polynomials in the way we talk about them in here, right? Because we don't care about the leading coefficient being non-zero because well, this is linear algebra, right? So, I mean, I guess you can still care, but not in the. All right, I'm gonna go on. Oh, by the way, I thought it was kind of cool. If you notice, there's something neat here about this problem. You can actually look at the matrix as being the tensor product of the identity with the corresponding complex matrix. If you were to look at the complex basis, this and that, with complex coefficients, the matrix would be 2, 0, 0, 0, 1, 0. And then like if you take the tensor product of this with the identity matrix, it blows the 2 up to 2, 0, 0, 2, and the 1 to 1, 0, 0, 1, and everything else zeros. Kind of neat. Just saying. I don't know what it means. Just something I noticed. Probably don't need to worry about that. What is this? Oh, I need to make this clear. Am I still in focus, Daniel? Probably wasn't in focus before. Oh well. Is that okay? Okay. All right, so this one actually does require some actual calculation, right? So I've given you an annoying non-standard, let's say, basis for P2, right? X squared plus x, x squared plus 3x. Thanks for the correction, it's Saturday. And then x plus 1, now they're linearly independent with that 3 there. So first of all, I asked you to show that beta is a basis for P2, and then define the coordinate vector of an arbitrary thing. In contrast to the earlier problem of the quiz, you can't just slap these things in a matrix and invert them, right? You can't, there's no, phi beta of b equals to beta inverse of b. It's like a trick formula here, right? You just have to work it out. I mean, you can work it out by writing the maps that we wrote earlier, but I don't think it really saves you much work in terms of an explicit example. The mapping things I wrote before were to understand the role of the interrelation of coordinates and transformations, but as far as specific problems go, I really think your best approach is just from the definition, So I decided that I was basically going to calculate, I was going to show that it spanned first, because then I could show linear independence real easy. That's just my choice. You could show linear independence first if you wanted. That's not wrong. I'm just being lazy. So C1 times this plus C2 times that plus C3 times that, that's what I want to make equal to AX squared plus BX plus C. If I can do that, right, if there is a solution to this equation, it then follows that the coordinates of AX squared plus BX plus C are C1 comma C2 comma C3, right? So how do you solve this equation? Well, you equate coefficients of x squared, x, and 1, right? Which we proved were linearly independent at some point. So I can equate coefficients. And so I get equations, right? Hopefully these ones are right. C3 equals to C. C1 plus C2 is equal to A. And C1 plus 3C2 plus C3 is equal to B, just equating the coefficients of x squared, x, and 1, all right? And then you got to solve these equations. Right? I chose to add equations and just solve them brute force. You could put them in a matrix and do row reduction if you wanted, right? But certainly you shouldn't just write the problem down and write the matrix next and then do calculation. There needs to be a sentence or two explaining what you're doing. It's not okay to just jump to the system of equations without this writing up here. That writing is not optional. You must explain what you're doing. So anyway, you do the algebra, which is slightly non-trivial, not too bad though. And after a bit, I found C1 was this, C2 was that, and C3 was equal to C. Okay, at that point, that algebra holds in general, right? So I can easily prove linear independence now. If I set C1, B1 plus C2, B2 plus C3, B3 equal to 0, right? That means that that means that I can get that C1 is 0, C2 is 0, and C3 is 0 because I have that C1 is this, right? C2 is this, and C3 is that. But you know, if this is equal to 0 times x squared plus 0 times x plus 0 times 1, that means A, B, and C are 0. So I plug 0 up in these formulas and I get 0, 0, 0, right? Which proves then that the set is linearly independent. So that, I mean, once I have the coordinate formula, I can actually prove linear independence with a sentence. So I don't need to redo the algebra, is my point. If my card's right. Now, if you did the algebra twice, once for linear independence and once for spanning, that's not wrong. You know, it's not wrong. In fact, that's not a bad thing at all. You might be able to discover if you made a mistake in the algebra by doing it twice. You know. Of course, it's always a good idea to check your answer, right? So if I'm right, you should be able to multiply this stuff out and get back to ax squared plus bx plus c, right? And I don't usually check the whole thing. Like personally, I usually check just one thing just to be safe. Here, I think I checked the x squared. So like x squared should give me a. Look where you have x squared. Here, 3/2. Here, minus 1/2 a, right? And so that gives me 3/2 minus 1/2 a, and that's an a. And how about the other terms? I also have a minus b over 2 plus c over 2. But then over here, I have a plus b over 2 minus c over 2. So those cancel, just leaving you the a. And you can check the other things too. You can check that the algebra works, right? So once that's done, that's the coordinate mapping, right? Which incidentally, by the way, shows you that what? That beta is a the beta is spanning a generating set, right? Because you can pick any ax squared plus bx plus c, and this linear combination with these coefficients will give you back ax squared plus bx plus c, which shows the beta is the generating, spanning set. I don't think I asked for that. What did I ask for the stretch problem though? I can't remember.
Proof B is a basis for.
B is basis, yeah. So I'm arguing that. I don't think my argument is quite complete here. I probably have to take a point off. Maybe two. I guess how much work? Depends on how much work. Oh, okay. Your homework is in transit. You really need to write down the points. That's probably good. Just give everybody 100? No.
Yeah.
I think I have the grades and everything.
What?
I
Oh,
don't have it.
you can just write it on a piece of paper. We'll put it in.
Okay.
Yeah, it's fine.
I'll steal.
Yeah. I noticed Philo has not put the quiz 2 grade in. Like, what? No, where is that?
The what?
Quiz 2.
Did you put-
No, I mean quiz 1. Quiz 1, I'm saying. I was looking at your grade book, I'm like, wait, where's quiz 1?
100.
It was all 100.
Well,
Make my assessor thing.
Okay, so were there any questions about this one?
So what I did was I said, since it's linearly independent, I said like proposition 6.6.8, basically if the dimension of P2 equals the dimension of beta, then
Right.
beta is the basis.
Yes, we could use that argument here, since we know P2 is three-dimensional. Once I show I have three things which are linearly independent, we automatically know it's a spanning set. That's true. The dimensions are known here. That's a reasonable argument. But I'm just saying, once I write down the coordinate map, which is an invertible linear transformation, like proving, you can easily prove the spanning thing once you have this. I mean, it's like almost immediate. You pick me a point, ax squared plus bx plus c. I tell you this many v1s, this many v2s, this many v3s added together and give me back that. So that proves spanning. I mean, but your argument's right. You don't have to say that. You know. There's more than one way to prove something's a basis, right? But somehow we have to give, either the dimension is known for the space, in which case it suffices to either prove linear independence or spanning, right? But if the dimension's not known, or it's not given to be known, right, then you have to prove both, right? Yeah.
And the linear independence thing, you got C1, C2, and C3 all being equal to 0 by setting the thing right above it, all three of those equations equal to 0 and solve them.
Right. The reason I know that the right-hand side of those three equations is 0 is because 0, right, is equal to 0x squared plus 0x plus
That proves
0 times 1. That proves the A, B, and C are 0. And then the formula above. What I'm trying to say is I'm missing about a quarter page of writing here to make a complete argument, okay? Sorry, I was in a bit of a hurry when I wrote this one. I was much more careful about the earlier one. Yes?
Where's the part 2 question? There's another question after the basic. Bunch of V beta.
That was what's down there. This is V beta.
Oh,
I mean, another notation for this is V beta. This is V. This is V sub beta. It's also another notation we have for it is V sub beta, V.
so how to write the for the first part for the basis? There are two questions, right?
Yeah, I know. I'm not. I was talking about how to show it's a basis. I mean, you have to show it's linearly independent, and then it's a spanning set. Or use the theorem Crystal talked about, which says that since we know quadratic polynomials are three-dimensional, if I can either prove they're linearly independent, then it automatically follows that they're spanning set because we have a theorem that says if you have one, you have the other. If the dimension is known, right? So I have up here that I have an argument here that the linear independence, for linear independence. But I mean,
That makes sense. First one is like a proof question.
look, so you could do this. C1 x squared plus x plus C2 times x squared plus 3x plus C3 times what? X plus 1 equals to 0. All right? So suppose this. Then what's that give me? That gives me C1 plus C2 times x squared plus C1 plus 3C2 plus C3 times x plus C3 is equal to 0. Okay? Which then implies by linear independence of x squared, x, and 1, that C1 plus C2 is equal to 0. C1 plus 3C2 plus C3 is equal to 0. And finally C3 is equal to 0. Well, C3 equal to 0 is very nice, right? And let me call this thing 1. Let me call this thing 2. So if I take 2 minus 1, that gives me what? That gives me
C2 is
2C2 plus C3 equal to 0, right? But C3 was 0. So that implies that C2 is equal to 0. Therefore, from 1, we find what? Right. That proves it's linearly independent. But the dimension of P2 is equal to 3. And the number of things in beta is equal to 3. Thus, the span of beta is equal to P2. And therefore, beta is basis. Now, this thus is the theorem that Chris was quoting from the notes, proposition 6.8. I don't require you to proposition numbers, so like on the test, collecting the hypothesis and then saying thus by theorem or just thus in this case would be enough. Now, if I say show this as a basis by showing linearly independent and a spanning set, then you had best show that it's both linearly independent and a spanning set. I wouldn't be happy if you used the theorem, if I used that wording. You know? So, if you're in doubt, ask me. Did I mention that? If you're in doubt about what I'm asking in the question, ask me. Okay, I will actually tell you my intention with the question. I don't mean that to be hidden. It's not, I'm not trying to play games with you. I'm asking you pretty straightforward questions where you use the definition and write stuff down. For the most part, I mean, there will be a problem or two on there that are harder, but. Okay, how about this one? So you're supposed to show gamma as a linearly independent set. So, what do? You notice I do not write, I didn't grade these, but I sure hope that on your paper you don't have a matrix with 4-dimensional vectors and row reductions without explanation. You don't have to tell me if you did that, but odds are there's about 5 of you who did that. If you're like any other year of linear algebra I've ever taught. People just automatically go, well, I'll just change these to 4 vectors and do it on that. It must be the same. Probably, but you know, the whole point of this is to give clear, concise arguments about linear structure. And so when you just like, at the start of your logic is this fuzzy logical like equivalence thing, it just destroys the whole point of the whole discussion, you know? And so be clear, be concise. Try. Anyway, so this linear combination set equal to 0. If I can show then what? C1, C2, and C3 is 0, that shows linear independence. And again, once you do that, you get 3 interesting equations, right? And then solve them. And you get C1, C2, and C3 are 0. Right? Now you could use a row reduction to do the solution, or you could just add equations. I mean, it's up to you. What do you think is easiest depending on the problem, right? I suppose if I give you a problem with like 7 vectors and ask you to show it's linearly independent and the equations aren't sparse, you probably should use row reduction, right? But then again, you're like, but I have an hour test, so that problem's not on the test. That is good test-taking logic, you're probably right. Although, I could put a problem with 7, and then I could give you like 5 different row reductions already worked out, and then you have to choose the correct one from those.
That's so mean.
So it's not really out. It's just a lot of work for me to put it on a test. Think about it.
But mathematicians.
That'd be the first time I've ever seen multiple choice on a math test.
That was the first time. Oh, that reminds me, Bailey told me to put multiple choice on your test.
That's probably
As long as I can circle an answer and it still works.
Yeah,
I'm afraid.
I mean,
if we're not gonna have,
I
there's gonna be a time crunch issue, then I would like
give it to choice.
I make no promises about multiple choice. I mean, sometimes I'll ask multiple choice if I really am just interested in the answer and I don't really care how you explain it. Or I just don't want to see how you explain it.
Definitions.
Is that often though?
For definitions, that'd be great. Do a multiple choice for definitions.
Multiple choice definitions. Which one of these is a definition? I'm pretty sure that doesn't make
Multiple
sense.
choice proofs.
No, I mean like which one of these different definitions?
I know what you mean. We know what you mean, Christian.
So, we've had like,
Although it might confuse us looking at the wrong
Choose
answer
one of
and
these
like
proofs.
using that definition for another proof.
All right, but getting back to, let's get back on task here.
Sorry.
W is traceless matrices, right? So that means that the sum of the diagonals is 0. If I use the word trace on the test and I forgot to define it, hey, you're totally within bounds to ask me what that means. Like, I don't care. That's not a big deal. I will tell you, right?
The definition of trace is in the notes then.
Yeah,
Oh,
of course. Sum of the diagonals. And to say traceless just means it's trace 0, right? Anyway, so here's a generic, this is a generic point, right? You have to take a generic point in the subspace, and to show that gamma is a spanning set, I have to show that I can reach that generic point by a linear combination of the things in the basis, right? Which means I have to solve these 4 equations. 1, 1, 1, 2, 2, 1, 2, 2. Of course, the 1, 1 and the 2, 2 are degenerate. They're the same equation. I really only need to pay attention to 3 of these equations. This one and this one and this one. And just for something different, I mean, of course you could just brute force add and subtract equations again, right? But I figured to give row reduction its due, I would convert it to a matrix problem, right? But again, just to try to, I mean, not to beat a dead horse, but why do people really care about that anyway? I mean, sorry to guess. But, you know, you cannot just write this down. If you read the problem statement, and then you write this down and start doing stuff. That to me says you don't care about what I'm telling you today, which is you must explain your work. So this is only coming after a discussion which leads to these equations, right? You shouldn't look at the solution and discard all of this as just blah, 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 blah. Oh, here's how you actually do it. No, this is how you actually do it. This is the blah, 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 blah. This is much more important than this in this part of the course. Okay. Hopefully I haven't sufficiently animated to burn into your memory.
You'd be
So-
great in my character.
Oh, thank you. I'd be so awesome at shadow clones. Doing so much math. I mean, think about it.
You'll be able to teach every course at this school.
Ooh. And if I could keep the shadow clone teaching physics to from coming back to me, I would I would never really regain that experience. I would never really feel like I'd been teaching physics. It would be as if I wasn't teaching physics.
Aren't you teaching physics next semester?
Why don't you just teach, why don't you just
Like, why
have
are
the
the only
shadow
two
clone teach
people?
one?
Or you could just
And
get
then
to
teach the next one, and so on and so forth.
Do what?
Just teach lab for you.
Just teach the lab for me.
At 7:50 lab.
And you guys
I don't
teach
think
my
I
lab?
have some decent.
I'll teach lab.
You'll teach my lab for me next week? What's it worth to you?
I'll teach you a lot.
It's worth
Yeah,
some
it's worth
extra
it.
5 extra
It's
credit
fine.
points.
I'll do it
Like,
for
I
free.
can't do it.
Oh, I shouldn't miss my camera.
and you
Oh, well.
just tell me.
I'm not going to do this, ever.
My people will contact you.
My people will talk. Yes, so
I actually probably know it.
let me go. Let me just finish the thought here, and then I'll take your question. Sure. So you solve the system of equations, and I'm not a slave to row reduction, so I don't feel that I do not need to get to the identity. All right, I just need to get far enough so that I can see how to back substitute with ease. Once I've got this, that means that 2 times C3 is equal to that thing. So I'm done with C3, right? Enough. So C3 is oh, excuse me, I'm an idiot. Why do I say, oh, what?
I think you skipped stuff.
That's not cool. What have I done? This is all wrong.
Oh,
Gosh,
no. Okay, can you
Actually, wait.
can you explain to us what's wrong?
No, wait a minute, because it's your answer.
Oh, Landon's wrong.
What? My answer's good.
Did you use?
It's your answer too. No?
I don't see anything wrong.
Well, what am I thinking wrong then? I was thinking 2 times C3 was equal to that, but over there I've got C3 is equal to C minus C2. How do I have?
I didn't even use a matrix.
I think you just said it was.
Oh,
you
this
switched
is supposed to
two
be a
and
C3 is all that is. This is a typo. That is C3. I'm sorry, that's what's bothering me. I treated it as C3 past this point, right? Like down here, here it is here's the real C3.
I get,
No, that's C2, I'm sorry.
What? Hold up.
what?
You've lost me.
How do you
I'm
get
lost.
3A minus B minus C over 2?
I think I have an even number of errors that cancel out here.
Now I'm really confused. Can you help me out here?
The answer is correct. This algebra is riddled with typos, okay?
Can I
But just let us just summarize it as this. You solve this system of 3 equations, right, with these 3 arbitrary constants A, B, C, and you get this is C1, this is C2, and this is C3. I could work those out again, but that really wouldn't be a good.
The purpose is that we're solving that system of equations.
Right, and you should expect that A, B, and C are going to be your answer, right? Because you're trying to find the coordinates, basically, of something that's parameterized by A, B, and C. So, if my basis was easier, if my basis was just, the natural thing, in this case, E12, excuse me, if it was like E11 minus E22, so like 1, 0, 0, minus 1, and then 0, 1, 0, 0, and then 0, 0, 1, 0, then the coordinate vector would just be ABC, right? No. You know what I'm saying?
I'm saying you should have done that, but not.
Well, my thinking was that if I did something that wasn't that simple, that it would actually give you an opportunity to think through the coordinate map. So I hope it served its purpose. Here, I just rattled something off, let me just write it down so you have a more concrete thing. So what I'm saying is if I had, what did I use, gamma here? Suppose I had gamma tilde equal to 1, 0, 0, minus 1, 0, 1, 0, 0. I mean, this would be my go-to choice for a basis for the traceless matrices. What I wrote down in this problem was deliberately complicated. Okay? So in this, if I asked you what the coordinate was of A, B, C minus A, like this, what's the coordinate vector with respect to the gamma tilde basis? The answer is just, well, I need A of these, plus B of those, plus C of those to get back that vector, right? So that means the coordinate vector is in fact just A, B, C. This problem is harder because the matrices that you're adding together, they're all kind of jumbled together, right? Like, the reason that this algebra got in the way is because this and this are kind of all together, right? And then these guys are intertwined with those guys, and then even this and this interfere with that and that. So there's all this kind of coupling, right? As is evidenced by the fact that A, B, and C are in each one of the coordinate formulas, yeah.
Do you have like 3/2 A in the very first term of the thing?
Like I said, you gotta solve the algebra. Did you have 3/2 A?
I have a different answer.
Oh, you don't have 3? Oh, so my answer's wrong, I guess so.
Uh-oh.
I did say I didn't grade this one, right?
Okay, I'm just gonna,
Yeah, so that's why I didn't see it.
I'm just gonna, oh, this is wrong.
Yes. Indeed.
And I'm just
You
gonna
should
solve the system of equations myself. And see
solve
what
the
I
system of equations yourself, and what will you get? Landon or Daniel, what do you guys
I
say?
had 1/2, well, for the first thing, 1/2 A plus 1/2 B minus 1/2 C. And then the second one was 1/2 A minus 1/2 B plus 1/2 C. And then the third one was minus 1/2 A plus 1/2 B plus 1/2 C.
And do you agree, Daniel?
Not on the second one.
No.
Oh, no.
Let me tell you that.
Can we just like scrap this problem?
No. If you know me at all, you should realize that you're greatly increasing the chances that are on the test at the moment. Anyway, what are you taking?
For the second one, I found
What?
minus A plus B plus C over 2.
Oh, minus A plus B? Minus C or plus C? Plus C over 2?
Should I just go through and check to see which one is
So, yeah.
I don't even know.
Okay.
Wait, what are all of them?
These are two potential, this is A gamma this, or possibly the same. So we're pretty sure on the first and the third, and there's some possible disagreement on the middle
So
component.
the 3 isn't part of that for the first one on A?
Oh wait,
3.
and the third one. I was sorry.
Oh, what?
For the third vector, or for the third component.
Third component, yeah.
Minus A minus B plus 3C.
Minus A plus B
No,
Minus B.
plus 3C.
plus 3C. Okay. Fine. My goodness gracious.
Did I add it?
You just erased it all. Okay, whatever. I don't even care anymore. I'm just gonna solve it and see what I get.
I mean, nuts.
I'm just gonna solve it and see what I get. I don't know.
Need 3 seconds. Can you focus it over your C1 plus C2 or something? And A. C1 plus C3 is B. C2 plus C3 is C. So I can eliminate C1 by subtracting these two. And I get C3 minus C2 is equal to B minus A. And then I've got C3 plus C2 is equal to C. Add these, C2's cancel, you get 2C3 is equal to B minus A plus C. So therefore, C3 is equal to B minus A plus C over 2.
Oh.
I think. Did I make a mistake? So there's C3. I haven't made a mistake.
A minus A plus C. I have an answer on that.
Oh, really?
Yeah. Actually, funny thing, your answer at the end. Oh no, it's still, it's not correct. Your answer in the end is also wrong. So all three of you were wrong.
Or I made a mistake now.
Or you made a mistake now. Who knows? At this point, I don't even.
I grow weary of this example.
If I subtract these two, I get C1 minus C2 is equal to B minus C, and then I've got C1 plus C2 is equal to A. So if I add these, I get 2C1 is equal to A plus B minus C. So therefore, C1 is A plus B minus C over those. And then pick your favorite thing and get C2. C2 is equal to A minus C1, which is equal to, so I get 2A, so I get 3A plus B minus C over 2. There you go.
No.
No? What'd I do?
How are every single
No,
one of these
no.
wrong? I don't even understand.
And then it's-
C2, if C3 is not in.
A minus C1.
No.
When I added mine, they added up correctly.
You checked your answer and they were. Yeah. What did I do? This one?
C2
Yeah.
is wrong.
Yeah, it should be a 3 now.
I think it should just be one now.
I think it would be
Or A minus C1?
A minus B.
Oh, A minus C1, duh, so
Okay.
that's a minus, oh, no, it's just
Okay.
that.
And then
Yeah,
minus
and
B
then
plus C.
minus B
Plus C.
Plus C.
plus C2, because I gotta distribute the minus,
Yeah.
That's what I get for not writing that step. Otherwise, okay?
A minus B plus C.
All right.
Oh, okay, so Landon was right.
Mm.
Yeah, then.
On this parameter only. Oh, and the other one.
All right, I'm going on. Thank you.
Yeah. I'm having too much fun with this.
Problem 9. Oops. Problem 9 here. A lot of the trouble is really picking the right starting point. Now, if you had started with t of ax squared plus bx plus c, sorry about that. That is definitely the wrong way to start. Whenever you're trying to figure out, if you're trying to figure out, like the matrix of linear transformation with respect to, some abstract vector space, it's in your best interest to pick a natural expansion in the domain. The natural expansion in the domain respects the basis which you're given. Okay, so like here I'm given basis beta, which has x squared plus x squared plus 3x, x plus 1. So that's why I chose this, this, and this. Because that makes the coordinate vector of fx just abc, which is good for what follows. All right? If you used ax squared plus bx plus c there, I don't want to know about it. I don't want to see it. That hurts my head. Okay, because, hush up. That is the way to do it. If you do that, then you just follow the definition, f of 0, f prime of 0, f prime of 0 minus f of 0, you get those over there, right? C, a plus 3b plus c, 2a plus 2b, and minus c. And I got that from differentiating, right, and then plugging in 0 into these. Okay, so look at what you got. You've got your image of f of x is that matrix, right? But you need to figure out the coordinate vector of it with respect to the gamma basis, right? Because eventually you're going to want to eventually you're going to want to do what? You're going to want to find the matrix T beta gamma such that when you multiply by f of x, it's the beta, you get back what? You get back T f of x